So a few hundred years ago, scientists started having the ability to do experiments on gases. And one of the first experiments that was done by a man named Boyle, and he came up with Boyle's law. And what he discovered was that if he looked at a gas whose temperature was the same and whose number of moles was the same, that the pressure and the volume were inversely proportional, meaning as we increase our volume, and here's a little piston here, the volume inside this piston is increasing inside the tube is increasing as we pull the piston up, our volume is increasing, and the pressure goes down. And then if we decrease our pressure by pushing down on the piston, then our pressure increases. So as one goes up, the other goes down. That's what we mean by inversely proportional. Now, pressure times volume for a given system, so if this was closed, if the gas was not allowed to leave here, this would be considered a system. The pressure times the volume at one point in time is going to be equal to the pressure times the volume at another point in time. So here, as long as we're not letting the gas escape here, the pressure at this point times the volume at this point is going to be equal to the pressure times the volume at this point. Now the difference is here our volume is large and our pressure is small. And in this case, our volume is small, but our pressure is large. And even though our pressure changes, our pressure 1 is not equal to our second pressure. Our second pressure is much larger, and our volumes are not the same. Our volume 1 is much larger than our second volume. The product of these two values is the same. So we can use this relationship to solve problems. Now, we can think about this quantitatively, looking at a simple system. Here we have a volume of gas, and this gas has a piston here that can go up and down, so we can change its volume. And if we have 1 liter of a gas whose pressure is 1 atmosphere, and we push down on this piston and make its volume half of what it originally was, our new pressure is going to be twice that. And if we look at these two relationships, pressure 1 and volume 1, we multiply these together, we'll get 1. And we look at these two, the second pressure and the second volume, we multiply these together. 2 times 1/2 is 1. So the product is the same on both sides, pressure times volume, pressure times volume. Now, in both cases, the number of moles of gases is staying the same, and the temperature is staying the same. All we're varying is the volume and the pressure. And as one goes down, the other goes up. So how does this relate to the kinetic molecular theory? We know from our everyday life, from dealing with pumps and balloons, that the volume of a gas is inversely proportional to the pressure. If we decrease the volume, our pressure is going to increase. Well, using the kinetic molecular theory, we can explain this because as we decrease the volume, the molecules, of course, are going to be in a smaller space. That means that the gas molecules are going to collide with one another and the container wall much more frequently. And this increase in collision means we have more force per area, which means we have greater pressure. Now let's look at diving and how Boyle's law manifests itself in diving. We know that water is much, much more dense than air. And when divers descend into water, the pressure due to the mass of the water above them is very substantial. Every 10 meters, or about every 10 yards, that you dive below the surface, the pressure on your whole body, including your lungs, increases by 1 atmosphere. So if you go down 10 feet, it's going to increase from 1 atmosphere to 2 atmospheres. Down 20 yards, it's gone up to 3 atmospheres. Now, if the tank that a scuba diver had only contained air at 1 atmosphere, which is atmospheric pressure at sea level, you would not have the muscular strength to inhale it into your lungs. Human beings only have enough force to overcome about 1.06 atmospheres. This pressure due to the water would force all of the air out of your lungs. Excuse me. However, scuba tanks have regulators so that the air from the tank is delivered at the same pressure as the water that surrounds you. This allows you to inhale air even when there's large pressure outside. If you didn't have that regulator, then the force of the water would push in on your body and cause the air to be pushed out. Now, this also is something to take into consideration when a diver goes back up to the surface. Because as she goes, or he goes back up to the surface, the pressure is dropping. And so as the pressure drops, as the pressure goes down, volume is going to go up. So let's look at lungs. Let's say a diver holds her breath and rises to the surface quickly. So she goes from 20 feet up to the surface very quickly without exhaling. Well, we have a closed system here because she's not exhaling. The lungs are acting as balloons that are holding in the air. And as the outside pressure decreases, what's going to happen is the volume of these containers of gas are going to increase by a factor of 3. Now, lungs weren't designed to do that. Lungs are not balloons. They're made out of tissue. And so the air inside them would cause your lungs to basically explode. So always exhale when rising. And that will allow you to not have a closed system. And then your pressure within your lungs can be regulated or into equilibrium with the outside pressure. So you scuba divers out there, always exhale when rising.